Hi guys, 6 Yankee 1 X-Ray here. Well, some of you will know what that is in front of you and some people won't know what it is. So, to let everybody know, these are 800 watt, 100 ohm RF hybrid modules or resistors, and you can guess what they're for. A project I'm building, a dummy load. But not just any dummy load. It is going to be a lot more than that when it's complete. But I'm going to start out with probably doing about 3 videos on this. And the first one is just going to take you through building a very basic dummy load that's going to be really nice looking, that will be able to handle, these dummy loads, this can handle 1600 watts comfortably if you have the proper heat sinks, and it'll even go up to 3000 watts if you can cool it properly for a short period of time. But continuous hold down, you'd be able to go up to about 1500, 1600 watts, no problem. But I'm not interested in that really. I would never be keying down an amplifier for very long. One, and two, mainly what I would be keying down for long periods might be a HF radio running at 100 watts, 200 watts, or 400 watts maximum. But for tuning up an amplifier and so forth, these will easily tune up a full legal limit amp. So that's one of the reasons why I decided to use them. And as you can see, they are really small, and they work really well. These are 5% tolerance, which when combined in parallel, the two 100 ohms will give you 50 ohms. And of course, because they're in parallel, the error will be less than 5% at that point. So hopefully you get an SWR of somewhere around 1.1. Hopefully that'll be around the figure I'm expecting to get from this. And we'll see how it goes. They have a maximum temperature rating of 100 degrees C, and then they start to derate, and at 150 degrees Celsius they totally derate. So, and will destroy at probably that point. So you want to keep them, within 100 degrees Celsius at all times. Now, here's the beauty of this that you guys are going to love. The price. Basically, these pair of hybrids cost me $70 for the two of them. And I bought a really nice case out of China. It's a 2107 aluminum case. Not optimal, but I didn't want to go too big with this. I wanted to keep the size relatively as small as I could get away with. I plan to use active cooling with fans and so forth. Even though this case does use external fins, I can still cool it to an extent internally on the other side of the heatsink. So the only other problem I had was that I needed some cable to hook up these pair in parallel. And what you'd ideally want to do is have something that is 100 ohms reactive cable, which normally you have 50 ohm is what we use. That would throw the SWR out. You're probably talking 1.2, 1.3, I don't know, but somewhere like that. You could use a twisted pair of wires to run it, Teflon wire or something like that. Or the best solution would be RG62 cable, which is 93 ohms, very, very close to what you really want. And that was very hard to get. We're going to take a look at this now. I'm going to try to put this together into as quick a video as I can. And I'm first going to just show you what I have in terms of the case that came from China. So here's the case. This is how it came. It came in a really small package. They actually stacked, they wrapped each piece in bubble wrap, and then did like 2 turns, wrap this on top, wrap that on top. And I was really, when I saw it, I was like, wow, this thing is so small, this can't be what I ordered. But then when you put it together, it's not bad at all. The front panel is pretty thick, a piece of aluminum. Now what you see here is I've already drilled these out, and here on the heat sinks I've already drilled out for the hybrid modules to mount, and you can still see my pencil lines in there where I marked it out. And this is basically the two heat sinks that you get with the order. And this case is a 2107 aluminum case, and it was $39 US on eBay. And sorry about all the fingerprints. It's anodized aluminum. It's not bad. There is going to be a couple issues that I'm going to have to build some internal stuff for the cooling, but that's not a problem. It has now it comes with two pre-drilled holes here for phono jacks or something. I already installed, couldn't bother to take these out. The caps, you just get these caps in there with it. And it has I already put in the power plug. It has a power plug. So that's been drilled already, as you can see. And that's ready to go. So everything is ready. So I'm going to assemble this. Now, I have a whole bunch of other parts right here. I have these parts here, PL259 female ends to go into the case, and those will mount down here. Like so. And I've got all my screws. I've got the chassis screws, and this came with rubber feet also for the bottom, which I have not drilled. It comes with them drilled. You drill them, fit them in. I didn't even carry those with me home. I took this home because I need to take a check on a couple things here at the house and not do it down at my little lab at my office. And also I have the RG62 cable, and I don't know if you can see that, but yes, this is 93 ohm cable. And once again, I have to thank NJ1K Tom for sending me this. I won't need as much, but that's that. But basically, guys, here's what you got here. For under $200, it costs me, as I said before, $70 for the modules, the hybrid modules. It cost me $70 for the hybrid modules, $39 for the case, and to carry it to a machine shop and get everything drilled out and tapped costs me an additional about 25 US. So right there you're talking, you know, under $130 sorry, under $140 at that point. And you're probably going to want to add in a few other things that, look, basically this is probably going to cost you under $200 no matter how fancy you make this version of it. Yeah, so, and at the end of the day, what you're going to have is a beautiful looking dummy load that will give you 1500 watts tune up for a short period of time. Should be long enough to tune up your amp. You can mount in a switch here if you want, a light, a relay to select between in and out and go from dummy load out. All of that's possible. What I'm doing here in the video, I'm going even way beyond that with this, but I'm going to break it down into the video. For this one here is just basically, if you only want to spend under $200 to get a solid state dummy load, this is basically the video for that. The next part, I'm going to take it to another level, which I'm not going to give away the surprise on that. And that's what I really want it for. But for right now, I thought you guys might be interested in seeing this, because I know a lot of you, dummy loads are very expensive, and here's one you can build simply. And this was the case for this video. I just wanted to make it simple, that anybody out there could do this. The only thing, if you have your own tap and dies, you can cut off the $30. These were like $1 a piece. These are like 50 cents. Wish I could have gotten better ones. The nuts and screws, $5 worth. So really, this is, and it's easy to put together. And I have thermal paste, which is rated to 150 degrees C, which I bought. So, you know, that and some soldering and you're good to go. So I'll show you next my dry run, just checking out how everything fits together after it came back from the machine shop. You know, you marked out everything and it seemed to be okay there, but I want to put it together and see what it looks like as a completed unit. So I'll show you that next. Yeah, one of the questions I know I'm going to get, and let me just address it right now. People are going to say, oh no, this heatsink won't be able to cool it, it's not big enough, blah, 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 whatever. Look, bottom line on this is there are some upgrades that I can do to this. My initial thought on this was to add a copper spreader layer, and I actually plan to do that. But, as I said, right now, I want to see how hot it gets at different wattages, as is on the aluminum heat sinks. So for you guys out there thinking, well, this is not going to work, it's too limited, blah, 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 there are options that you can add on. And remember, I haven't even gone $150. You can put $50 more on. Go to a machine shop, get 2 pieces of copper that will be, you know, it doesn't have to be super thick. It can be, you know, the same thickness here, and you can drill out some more holes and bolt the copper down with thermal paste, and then just drill through here, tap again, and longer screws, and boom, you've got much more thermal mass on your dummy load. So options are open. This is just giving you a building block, and I hope people will improve on this and come out with better units based on this design or some other design or some other case. But if I'm building something, it's got to look good. That's one. It's got to operational. That's priority one. But it's also got to look good. And I like this case and the size. I need it in my lab. As I said, when I work, most of the time I want 100 watt, 200 watt dummy load I can key down into for long periods, because I get HF radios, guys come to bring them, ask me to repair them, and I need it in the lab, and I don't want it huge. I want something that's of a proper size that looks like a piece of lab equipment that can go down on my desk. So I just thought I'd add that in. Okay, well, I finished fitting it up. Just to do a preliminary check to see that all of the holes were drilled and tapped properly, that everything aligned up perfectly, and put together the case. So I guess this was a dry run to see that everything fit okay. As you can see what the case looks like now, fully assembled. The feet are not on it, so it's just resting flat. And at the back we have in the PL259 connectors, 2 RCA jacks, and inside I've mounted the hybrid modules on both sides. Just tested out put on the ground to make sure everything worked, and all the screws were long enough. The ones in the hybrid just made it with the lock washers and the flat washers. And the back there, I joined the grounds between the in and the output, just temporarily. And that's basically it. So now I'm going to pull the unit apart, back again, put on the thermal paste, fit it up and wire it up, and give it a test to see what kind of temperatures I get at 100 watts and at 800 watts, and go from there. That'll give me a better idea of what I'm dealing with in terms of how well these aluminum heat sinks work. I'm not overly optimistic on their own, and as I said before, I'd probably be adding a copper spreader onto it, but that everything will line up, the holes will be the same. Just drill out the holes in the copper to match, and then bolt the copper down onto the aluminum if this is needed. As I said, within what I'm going to be using this for, it might not be needed, but that's a look at it so far. Okay, well, it's all assembled. Decided to bring it up to the shack just to do some testing to see how it works in just a bare state. And you can see I've did some marking out there on various parts that, well, the fans and stuff that I'm going to put in later. And you can see the connection I did back here, not the neatest. This is just temporary. And you can see the hybrid modules mounted here and over here. And so let's plug her in and see what so far about $150 has gotten me. You know, I'm not, as I said at this point, expecting anything like near legal limit or anything, but you know, if it can do 400 or 500 watts with reasonable time length, then I'm pretty happy with that. This is, as I said, is just the preliminary stages. This is going to be upgraded quite a bit. And keep in mind, space is a major consideration for me. What space I have left over after I do just the dummy load, because there's a lot more to come. I don't want just this blank front panel here. There is going to be a lot more that I'll be adding to that. Okay, so let me hook her up right now and see how it works.